All right, we are here to work on systems of equations. So our system of equations here says 3x minus 2 equals y, and then negative 2y plus 3 equals x. So this is a system, so it involves two equations. We are going to use substitution to solve it. So I know a couple of things. I know that y equals 3x minus 2. I also know that x equals negative 2y plus 3. So I have two different ways to solve this. First thing I'm going to do is I'm going to take what y equals, and I'm going to put it in parentheses, and then I'm going to plug it in for y in the second equation. So I'm going to rewrite the second equation here. And instead of writing the word y, or the letter y, I'm going to write in what y equals. Y equals 3x minus 2. Then I'm going to write the rest of the equation. So plus 3 equals x. It's going to help me find what x equals. Now in this first part, I'm going to distribute the negative 2 to the 3x and then the negative 2 to the negative 2. So negative 2 times 3x is negative 6x. Negative 2 times negative 2 is a positive 4. Then I still just bring my positive 3 down here. I have it all equal x. From there, I would combine like terms. I would combine my 4 and my 3 together. I would just bring down my negative 6x. 4 plus 3, it's going to give me 7. That equals x. Now, I want to get my x isolated on one side. You might be thinking to take away this x, but actually we are going to add 6x to both sides to get x isolated on the right side of the equation here. When I add 6x to this ninja 1x, I get 7 equals 7x. Divide by 7. Divide by 7. I get 1 equals x. So when I do a solution, okay, or the answer to the system of equations, the solution is always a point. So I know that my x is going to be 1, and now I'm just trying to figure out what my y is going to be. So now that I have found that x equals 1, I'm going to take that thought and I'm going to go back and plug 1 back in here. Okay? So, since that's going to tell me what y equals, I'm going to do 3. And now I know down here that x equals 1. I'm going to type in times 1 minus 2 equals y. 3 times 1 is 3. 3 minus 2, hopefully we know that, oh boy. I get 1 equals y. And then I can go find my intersection point where these hit. Okay, I get 1, 1. That is how I would solve this by substitution. Now I'm going to use that same point and go back and see if I can do it the opposite way. I'm going to erase the whole thing and then plug in x for where y is. Let's see what that looks like. Okay, I know x equals negative 2y plus 3. So I'm going to take negative 2y plus 3 and I'm going to plug it in for x in the first equation. So I'm going to rewrite the first equation. 3, and then parentheses, negative 2y plus 3. And I got to rewrite the rest of the equation, so minus 2 I've got to still write, minus 2, and that equals y. Now I'm going to go through and solve it by distributing. 3 times negative 2y is negative 6y. 3 times positive 3 is positive 9. And I still have the subtract 2 on the back side. And that still equals y. Combine my middle-like terms right in here. I'm going to get negative 6y. And then I'm going to do positive 9 minus 2. That gets positive 7. Okay, and that equals y. This looks very familiar. I feel like we just did this. Now I'm going to add 6y to both sides to get my variables on the same side. Cancel those. Add 6y here. Remember, there's a ninja 1 there. So I get 7, which was on the left side, equals 1y plus 6y equals 7y. I divide to get y isolated completely, and I get 1 equals y. Does that check out? Let's see. Looks like we found 1 equals y. My x and y is 1 up there. Hooray. La-di-da. That excites me. All right. So we now know that that works out. I'm now going to put 1 in for y. I'm going to now plug 1 back in for y here to find out what x is. So I'm going to use this equation now. So I'm going to do negative 2 times y, which we just found out what y equals. Y equals 1. So I'm going to plug 1 in there. Okay. Plus 3 equals x. Well, we know negative 2 times 1, that's negative 2. Plus 3 equals x. Negative 2 plus 3, if you have to, use a calculator. That is 1 equals x. Okay, it looks like I got the same answers. Just showed you 2 different ways that you can possibly solve for a solution here whenever you have x alone and isolated and y alone and isolated.